Hello guys, this is a short video about my teaching skills on the conic sections, part of the geometric of within this mathematics subject. So we all know or this shape yeah, we all know this is in the shape of a bucket, and we call this as frustrum. This is conic section, and often the students in the class 8th or 9th of CBSE syllabus face this, that they are asked to find out the volume of this conic section. Now if you look at this is nothing but a section of cone, but volume of this depends on the radius, the small radius of the upper section, and the large radius of the bottom section, and it has got an overall height that's denoted by h. Right now, what is the volume of this frustrum? Now the straightforward answer is 1 by 3 by h r square plus r plus r square. Good, we know the answer, but do you know how to derive it? I mean, the fun part for any student is to understand where this whole thing is coming from. How do we derive it? So let's understand in a depth little more. So let me build a larger conic section. Apologies, I'm viewing it through my mobile camera, so it won't be all that accurate, the diagrams, so bear with that inaccuracies, but I'll cover the. So this is where my frustum ends, right, and this is my invisible cone. Again, I draw an axis so that it becomes easy to understand, right? This is my larger radius r, this is my small radius small, denoted with a small r, and I'll have to define it. The heights, define the heights. This is h, and let's define this by a small h, right? So how do I derive the volume of this section? This section, if I say denoted by say 1, volume 1, right? So this is my volume 1 minus volume 2, this is my volume 2. So 1 minus 2 is my volume of frustrum, if we agree all. So what is 1? 1 is basically a big cone, the formula for which we already know. This would be 1/3 pi r square h plus h. This is volume 1. I do it simple. Then what is the volume of smaller conic section? This area, this volume, I can denote it by 1/3 of pi r square h. So what is the volume of my frustrum? This will be denoted by 1 by 3 pi r square h plus h minus 1 by 3 pi r square h. Simple. But this does not exist in our problem statement. You see, I need to define this h in relation to the parameters that we have, which is this, and this. How do I do it? Let's explore our trigonometry. What basic trigonometric rules? Let me define this with an angle called theta. So tan theta, if I look at, which is this r by h, right? I can define tan theta as r by h, which is also same as r by h plus h. If somebody wants to refresh on what these trigonometric ratio mean, I'll set up I can take a separate video on that. So I'll define this as h plus h. So let me see what this brings out. R by h is equal to r by h plus h. I want to find out h. I want to define h with respect to all other variables. What do? I simply divide both the sides. I simply multiply both the sides by h. I get r into h, which is equal to r h plus h, right? So no, this doesn't exist now anymore, right? What I can do, I can bring this part on the left hand side, move it to the numerator. It becomes h plus h is equal to r into h by r. And then I bring this h back, bit the complicated affair, but we'll try this. 1 plus h by h is equal to r by r, and then simplify this further. I bring h by h is equal to r by r minus 1. Finally, I'm very close to defining what is h. H is nothing but h is equal to h by r minus r star r. Right now, move a bit closer, and then what we can do now is, now we know what the relationship between h and r. H is equal to hr by r minus r. Let me note it down here. H is equal to hr h small r r minus r. Now with this in hand, let's go back, revisit our formula, which was 1 by 3 pi r square h plus h minus 1/3 pi r square h, if you remember that from the previous discussion, right? So what I will do now, 1 by 3 pi r square h then plus 1/3 by r square h minus 1/3 by r square h. Now what we are worried about is defining h by the small h in terms of the larger variables r and h. R square h plus 1 by pi h r square minus r square, which is fine. Remember, 1/3 pi r square h plus 1/3 pi. Now let's bring back our h. Substitute this from here. This is h r minus r. If you know the expansion, that is a square minus b square is a plus b and a minus b. This goes off, so what we are left with is pi 1/3 pi r square h plus 1/3 pi r into r h plus 1/3 pi r square h. Now let's take out common factors. Pi h is common, take it out. R square plus r plus r square. This is easy to derive but harder to remember. Hence, a tool like this or a technique like this in the examination for any student will be helpful. More than examination, it's your own relying on your own understanding of trigonometry and basic arithmetics will help you come out of or identify the solution of a problem rather than just relying on a formula.